I didn't have time to watch the new movie yet, but oddly enough, I found the time to make this new tutorial. In this one, I have to first become one with the marker. To the intro. Gonna code, debug and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now. We begin with basic HTML. In the head, I'm just going to add a title for this project. And in the body, I'm going to define a canvas for the matrix rain effect, like this. And today is special. Today we're actually going to use two canvases. We are going to need one for the camera as well. So the way this will work is basically we have two canvases on top of each other and we make the shirt transparent somehow. And then on the back canvas we have the matrix rain effect, which is something that everybody does nowadays, especially when a movie comes out. So let me just close the body now and our HTML tag. And if I refresh now, nothing really happens here. But we do have the matrix canvas and the camera canvas. They are just transparent and one below each other there. So let me just go back to the code and we need to style these in CSS. I'm going to link our style sheet here and then go in the CSS and set a black background for the body, and I will remove the margins. The body usually has a default margin in many browsers, so I don't want that. And then for the canvas, I'm going to make it somehow visible. Usually the canvas is transparent by default, so I'm gonna put a white border around it so we can actually see it. And then I'm going to position these on top of each other in the center screen. So I'll do that by setting absolute positioning and then 50% from the top and from the left. But then we need to also translate backwards by -50%, -50%. And I will set width of this canvas to be maybe 98% of the screen width. I want to see the borders, and if I put it 100%, then the border on the left and on the right will not be visible. It's just right there on the margin of the browser. So let's give it a little bit of space. And now if I refresh, this looks a little bit different. So what we have here now is the same canvases, but they are actually overlapping each other. And we can see that their width is almost the full size of the screen here horizontally. Yeah. Now let's go back to our HTML page and start writing some JavaScript. I'm going to write a little bit of JavaScript here in the same HTML file. Usually you do this in external files, and we will. I have 3 external files here ready to make this effect. But I will just begin typing some JavaScript here because it's some general functionality that we need to access the video input and to start these effects. So I'm going to access the media devices from the navigator object, and I set here video to true, so we only need video in this effect. And when we are calling the getUserMedia object here, this actually returns a promise, so we need to call this then, and the function callback that we sent here will have access to the raw data coming from the video stream of the camera. So now I'm adding this raw data to a video object, just like that, and I will start playing the video. But doing this doesn't start the video immediately. It might take a few milliseconds for it to load, and to know that we are ready to display video somewhere or to process the video, we can use the unloaded data event here, where I'm going to set a callback function, and here we can do things like I'm going to access the camera canvas like this from the HTML DOM tree, and now I'm going to also set the width and the height of this canvas to that of the video that comes from my webcam. So depending on your webcam, we will probably have different values here for the width and height of the canvas. But I'll explain later about this. Now let's try to actually show an image from the camera on the canvas just to test if this works. So I'm going to use the drawing context of the canvas to draw an image from the video stream on the canvas, the full size of the camera canvas. So this is the same size as the video as you see here. And this might actually fail when we try to get media from the webcam. This might fail because maybe the user has not allowed to use camera, or maybe the device doesn't have a camera, or things like that. So if we get some kind of error there, I'm only going to alert it on the screen like this. Okay, now let's refresh, and you can see there now this static image of me. So it's not moving yet, it's just one image that we are getting when the video loads, and we are showing it on the camera canvas. That's it. We are only testing for now. And this is almost the whole code that we are going to write in this HTML file. I'm only doing this because of this elements here are easy to see which canvas I'm referring to, and things like that. Normally we write JavaScript in external files like what we are going to do next. But here let's look a little bit in the elements. So you can see that the matrix canvas still has a different height. So the matrix canvas is essentially shorter than our camera canvas, which has a height of 480 and a width of 640. This is the size that is coming from my webcam actually. So the video quality of my webcam is this resolution right here. But because we are scaling the canvas, so because we are making it have this width of 98%, no matter the size of your resolution there, you will still get this nice image that fills almost the entire screen. If I would disable this width to 98%, we actually see that this what it was 480 by 640 is bigger than the size of the screen. But while stretching it like this, we get it fitting nicely the way we want it. Okay, now let's get this static image of me animated. So I'm going to go back in the code, and let's include all the external JavaScript files that we will need. One of them will be this one for making my shirt see-through, so I'm just going to call it see-through.js. The other one is going to be the actual matrix rain effect. Let's call it matrix.js. And we will also use a third file where I'm going to put some utility functions that can be useful in other projects as well. Now, we don't need this debugging code from here anymore, really. But what I'm going to do now is initialize our see-through effect on the camera canvas and with the video object. So this see-through effect doesn't exist yet. We need to define it next, but that's all that we need to do here in the index.html file. So let me now go to the see-through.js and start writing our see-through effect here. Yeah, in JavaScript. And in the constructor, we are just passing the canvas and the video. These two objects are going to be the only ones we need, really. And I'm going to have a reference here of the context from the canvas so that I can access it later. And now I'm going to animate this effect. This animate will be a method inside of our see-through effect, where we are just going to draw the images coming from the video as we did previously, but now we are using this keyword here. This looks very much the same as the code we had previously, but now because this is an object, we need to use this to refer to the stored properties here. So let me now call also request animation frame. So this function is going to call our animate function as fast as possible. It will try to do it 60 times per second, so 60 frames per second. But if your computer is slower, it might have a lower frame rate. Now we pass this animate function to method to this request animation frame function, and this is going to just call itself again and again. But there is a problem here, because when we pass this animate to request animation frame, it forgets what this is. Basically, the scope will change to be inside of this request animation frame callback here. So we need to tell this animate to remember what this is. So basically this here refers to the see-through effect object that we are working with. And let me just close this now and refresh here. Great. So I think that now we have this working live image of me there, and probably I'm not going to need the other image below, which I usually put in the console. So I hope this will work fine, and I'm going to remove it now. Okay, now to make my shirt see-through, let's just call here a method called make see-through, and this is going to be something we need to work on next. Let's write it here, make see-through, and we are going to first get the image data of the canvas using the context object. So I'm going to get the image data of the entire canvas right here. So starting at the 0, 0, which is the top left corner, all the way to canvas width and canvas height at the bottom right corner. And let's just see how this image data object looks like. I'm going to log it in the console and refresh the page. Okay, so it's appearing here many times as the image refreshes, and if I click on one instance, we see it has a width of 640, a height of 480, but most important here is this data attribute, which has over 1 million items. This number is equal to 480 times 640 times 4, because every element in this huge array right here is actually every 4 elements here represent 1 pixel. So the first one is the red, the second one is the green, the third one is the blue, and the last one is the transparency or opacity. 255 here means that everything is visible, 100% opacity, and that's going to be the case with pretty much all webcams, because we don't have transparent pixels coming from here. But let me now just focus on the top left corner pixel to see the values from that one. Okay, so this is now the color of the top left corner pixel on the screen. So the one from here, pretty much. And maybe if I'm moving my hand in there, something will happen and these numbers will change more drastically. But what I want to do is actually see the color of my shirt as it's seen by this webcam here. So let me get up and okay, something like maybe 10 red, 100 green and 200 blue or something like that. So it's not pure blue. Yeah, it's not pure blue, but some kind of mixture of all three colors in there. And let me now make a reference of this color so we don't forget it. And I'm also going to define here a threshold, because when we are going to try to find the color of my shirt, you saw that the values are constantly changing there. So that pretty much means that my shirt is made of many different colors, even though we as people recognize it as blue. So we will have to match this color with a little bit of a tolerance. So I'm setting a threshold there for that. You'll see later when I actually use it. And now let's go through all the elements in that very long array. And notice here that I'm doing this by iterating I here every fourth element. So I'm jumping one pixel at a time with a group of four components there. So let's have here a reference to the red of each pixel, the green of each pixel, and the blue of each pixel value. And we could also have the alpha element on the like the fourth component, but we are not gonna use that, so I'm just gonna remove that here. It's just possible to access if you want it. And here we're going to try to see if there is a match between this every pixel that we are going to check in the image to the color that we defined earlier and under a threshold that we also set earlier to be 120 here in my selection. If this is a match, then I'm going to take the alpha value, so the fourth value here, and I'm going to set it to 0. I'm basically making this pixel transparent because it matches our blue value that we are looking for under a threshold. So we are going to need to write this color match function, but for now just bear for a second. I also need here to put this new image data back into the canvas starting at the top left corner. So after I modified it by making the bluish pixels transparent, then I'm going to put this back onto the canvas. And now we need to work on this color match function. And for that, I have to show you this example here. So colors can really be seen as points in 3 dimensions. So for example, if we add more red, you can see this as a moving along this red axis here. If we add also some green to this, then it moves also on the axis, vertical axis, but the end result is that your color is going to be a combination of this red and green. So any color that you see can be interpreted as a 3-dimensional vector or a point in 3D space. And the color that we are looking for was something like 10 red, 100 green, and 200 blue. So it was something here. This is the color of my shirt. I can't get, okay. So this is the color of my shirt here. Pretty much the one that we have seen in that console when I logged it earlier. But what happens is that my shirt has a bunch of different colors. They just get darker and brighter and so on. So we need to have a little bit of a tolerance here. Like if our color is going to be somewhere here, then we want to include that as well. And we do that by considering radius from this initial location. So notice I'm growing here a sphere from our one point that is our color here in the code. I'm growing a sphere with size 120. So this is going to be the threshold that we are okay with. And that means that if any color inside my shirt is inside this sphere, then it's going to be considered in our color match function that we need to write. So what we are going to do next is pretty much do that, and I hope this threshold is going to be okay. You shouldn't have a too large threshold because eventually this will include all possible colors, so it kind of defeats the purpose, doesn't it? Having the whole color cube accepted here. But if you go too small, then you might lose some important colors. Like some places my shirt is almost black, so you would like this to go closer to black, but not really include black itself, because my hair is also black, and yeah. Okay, so let's go back to the code now here and write our first utility function. So it's going to be this color match function. Given two colors and the threshold, we need to see if they are going to be a match. And if the distance between these two colors is going to be less than the threshold, then that means that we have a match. It means that C2 is inside the sphere centered on C1 with radius threshold, or vice versa. C1 is inside the sphere of C2 with the threshold. They mean the same. Threshold radius. They mean the same thing. So one of my viewers, I think it was Tim Holt, he noticed that you can just return this value here like so, and this color match function is now complete. I've written this function earlier, and I've used this an if statement here, but it's really not necessary. And the distance function is the Euclidean distance between 2 points. I've written this so many times that it's hilarious. So I should probably do a video of explaining it better, but it's essentially the length of the diagonal of a cuboid in 3D space in this case, because we have the 3D color space there. In 2D space, it's just the length of the hypotenuse in a triangle, so that uses the Pythagorean theorem. You actually can watch my video on the Pythagorean theorem. I think it's pretty good, and it explains a lot of things, but I should make one about this Euclidean distance. The formula is just this square root of the sums of square differences between the points. So you essentially use the Pythagorean theorem twice to get this Euclidean distance. But let me know in the comments if you want me to push that video forward. It has so many applications. I think it's really important that you understand this formula as a basic tool in any projects that you want to do. Okay, yeah, so now that we have this code complete here, let's go back to our project and refresh. Oh. I forgot to save this utils file. Let me refresh. Okay, and now something is happening here. I think I was quite lucky with that threshold. You can see my shirt is see-through, not perfectly see-through because some of the darker blues are not inside of the radius of this color that we defined here. So increasing this threshold, maybe 130, might include those as well. But now it looks a little bit like my hair is also included, even though my shirt looks better. So I'm just going to leave it as at 120. You'll see in the end that it doesn't matter. We don't have to match this color perfectly. The effect is still gonna look good. And if you're wondering, this line right here, it's actually the matrix canvas that we haven't done anything yet, and what we are gonna do things next. So there's another line probably somewhere here. Let's see if I can get that one visible by moving up. Yep. So, right. Now let's go back to our index.html file, and maybe I'm gonna comment out this see-through effect for now, so that we can really focus on the one in that comes, this matrix rain effect. And I think I'm gonna disappear from here when I refresh, so good that I'm recording with two cameras. I was wrong. I think that I'm not gonna need the other one anymore, and actually I think that I disappeared for some time, so post-processing needed. Anyway, let me now make this matrix canvas have the same size as the video canvas. Like if I refresh here, you will see that, okay, now I'm gone from there because this line is commented here, but the camera canvas is still being stretched to the proper dimensions. It just doesn't show the video. So the code is still working here. And the matrix canvas is the one that hasn't stretched. And we really want this to cover the same dimensions as the other one. So I'm gonna copy this code here and go here and change this to matrix canvas everywhere. And this matrix canvas is going to be used by our new effect. So let me define here our matrix effect, and this is going to use just this matrix canvas. It's actually, it doesn't need the video element at all. So we just need to write our matrix effect on this canvas and animate it right there. And this is going to be a very typical matrix rain video. Many people are doing videos on this topic. And let's move in our matrix.js file and start to write our effect here. So the matrix effect class is going to have a constructor that takes only the canvas where it's going to be animated on, and I'm going to store this canvas here, and let's have a quick reference to the canvas context as we did previously. And now we are going to need to draw characters here. So let's set a size for our characters to be drawn, and we need to figure out how big is going to be how many columns we will have. And this is pretty easy math. Okay, we just define whatever the canvas width is by the size of this character. So this is going to give us the number of characters that we can fit on the screen. And I'm using this floor function from the math library here because I want to work with integers, not floating point values. And when the characters are falling in this effect, they all have a position, an offset from the top of the screen. So let me just define an array of these offsets, and I'm going to be setting all of these values to 0. Like that. Oh, I realize here that I can actually use these columns. Like that. So this is now going to set all of these offsets to 0, and that means that we are going to start all characters from the same line, at least in the beginning for debugging purposes. And it will be at the top of the screen. Now we just animate, and let me write an animate method. This is pretty much the same type of function that we had previously, so I'm not explaining anything anymore. Okay, and in the animate we are going to set some kind of color, otherwise the characters are black, so let's make them white to be really visible, otherwise black on black we just don't see anything. And the font is going to include this character size, and let's have it Arial font. Now I also need to put here font weight bold, because characters are going to look more powerful like that. Otherwise, when the shirt is going to be in front, you will see the final effect has a little bit of a semi-see-through property to it. When I do that, then the characters are not so visible. So I think that bold here is a good idea. And now we are just going to go through all the columns and draw all the characters. I'm going to use this R character for now. We will randomize them later. But here what I'm doing is essentially drawing a character at the correct position. So based on the column index here, I multiply it by the character size so that it goes horizontally to where it needs to be, and vertically to offsets of whatever the offset there is. Now all of them are 0, but what we're going to do is increase these offsets by the character size. So at each frame our character will jump down by its size. And if I'm going to save this and refresh, you saw there these series of R characters going down from top to bottom of the screen. But because we're not clearing the canvas before we redraw every frame, it just looks like we are filling the screen with these R's there. So not something that we really want to do here. But also another thing that we should do is have the R's coming back from the top again. So if our offsets are going to be greater than the canvas height, we are going to put this offset back to 0. Now, if I'm going to refresh this page, you could actually see a little bit that the characters there are being drawn on top of each other, so they become essentially a little bit thicker. It's hard to explain, has to do with aliasing and some other things. But anyway, you could see that they are jumping back to the top. We also would want on every frame to probably clear the canvas. So if we clear the entire canvas like this, then we are going to go back here, refresh, and now you see just a line of R's going down. But there's a trick that we can do. Instead of doing this clear rectangle, we can go back here and say that we want to fill a rectangle and give this rectangle a black, a semi-transparent black. So let's give this RGBA of 000 for red, green, and blue. And for the transparency, let's put this 0.1 maybe. So now we're gonna fill a rectangle with this, but now we need these white font settings to be below it, like so. And now I'm gonna save the file, refresh the page, and you can see that there is a little bit of a trail left behind by the characters. And to make them offset, there's a trick you can do here when we are making them reset to 0, so the top part of the screen. We can do this with the probability. So if we are with the character down outside of the screen, we might let that character go a little bit more and then reset it to the top. And this is going to be random, so I'm going to say here and math.random less than 0.1 or so. So with a probability of 10% at each frame, this character will reset if it already left the screen. So let's try here to refresh now, and first time what happens is that all the characters go down in synchronized form, but then after that things start to go crazy like this. Now, one thing that we still should do is replace this character. So I'm going to replace this character with selecting a random character from a list. So let's define here at the top these characters, and I'm going to put here this long list of characters that I copied from actually from Frank's video. He did also a matrix rain effect recently, and he really tried to polish it more than I'm gonna do in this one, so do check it out if you're curious how he did it. So I think these are some Japanese characters. They look cool, so let's go with this. And here we will replace R with the random character from there. So we will say this characters and use the char at method. So we are going to get a character at a index, a random index from inside this array. So if we will put here 0, for example, then this will be the first character here. Let's actually try this to see it working. So now our character is that first character from there, but we want this to be random. So how do we randomize here? I'm going to use, let's have here index. So index is equal to math.random. We multiply this value by how many characters there are. So this characters length. And this is now going to scale the random value between 0 and 1 to a real value between 0 and how many characters there are in this list that I pasted. I'm also going to put this list in the video description, so if you want to use it, you can just copy paste it from there. So this is going to give us a real value here, so we need to do floor to get an integer value instead. And now I'm going to place this index right here and refresh the page to get something that looks like this. I think it's time to go back in index.html and make my image reappear here. So I'm uncommenting this part. And now you can see that the characters are coming in this part of my shirt where it becomes see-through. It's not perfect, it's not 100% ideal, but it's pretty good, I think. And what we are going to do next is make this shirt not perfectly see-through, so that you can still get an idea of what the colors are on my shirt, like the shadows and bright parts and things like that. So I'm going to go back to our see-through effect, and what we need to do here is modify this value we set to the alpha, to the opacity. So now we put it to 0, means that it's perfectly transparent. But we can actually put it to be how far away we are from our base color right here. So then our base color, if we find that one inside this image, then it's going to be completely transparent. It will let that black background fade in entirely. Otherwise, it's going to be less transparent. So you can still get a little bit of an idea of different shading on my shirt. So I'm going to put here our alpha value like this, and I'm going to define it as the distance between the RGB values and our color. So this distance is going to give us a value between, it can actually go beyond 255 because it's a diagonal of the color cube I showed earlier. So I think we can just go with this and see how it looks like. So I'm going to replace this alpha right here and refresh the page. And you can see now that my shirt is somehow not fully transparent. It's leaving some of this black background to go through. But we don't really want a black background here, I think. I think we want to keep the background to be the color that we are trying to detect in the first place. So still keep the shirt as blue in the beginning. And then here, where you see these sharper edges, we shouldn't be able to see those anymore. So this color from here should actually have be passed here already to the see-through effect, because now it needs to be passed to the matrix effect to use it instead of this black right here. So I'm going to take this color and put it here like so. Store it as an attribute and use it here as the attribute instead. So I'm going to need to put this dot color. The threshold can be hard-coded here, I think. Of course, to be really good, you can pass that one as well. So here in the index HTML, we can also pass the color as it was 10, 100, 200, I think, to the see-through effect, and let's pass it also to our matrix effect. So in the matrix effect class, we pass here in the constructor also this color, and store it as an attribute. And now we are going to use here the values from that instead. So let me just put here plus color of 0, and then plus color of 1, and plus color of 2. Notice that transparency is still there. We are going to be drawing a semi-transparent blue, actually. So, does this work? Let's refresh. Oh, color is not defined because we need to put here this color. This is an attribute. Refresh again. Okay, so now my shirt is still blue. Not exactly perfect right there, what is happening with these edge cases, but I think it's pretty good already. I'll let you figure out how to get those edges better. I think that we might have to use here in the see-through effect not the value of alpha, but maybe the value of maybe the amount of blue that we have there, or I don't know. I'm gonna just try something real quick, but if not, then it's your homework. Actually, because there is a step between our threshold value and this values that we are not selecting there, we need to divide here by the threshold, and then multiply all of this by 255. Yeah, I missed that. So now there is a smooth transition between these parts where the characters are visible and the characters are not visible. You can try experimenting also with other functions here, maybe applying the square root or the power. I think try applying a power value to this distance and you're gonna get some different gradient effects there. Or you can actually play with the colors that you're trying to detect. So I'm using blue in this one, but how about if we go here and give some other values here, like maybe 130, 230, 230. I'm trying to somehow isolate the background here. It's a guess, but yeah, it's a lucky guess. So basically I made the background be the thing that is becoming somewhat transparent, and I really like this. So find the code on my website and try experimenting with it and see what else you can do with this trick. And if you like this, please share this